is a reverse osmosis. So many of us heard this term, that is the reverse osmosis, because of this technology we are using at our home also. We had seen the water purifier. So under that small water purifier, we had seen one filter has been installed in that particular purifier. That is the RO has been there. So most of us had seen that kind of reverse osmosis filter media. So again, this is the membrane technology. So the driving force is the pressure, and thus it helps to remove the dissolved solids and dissolve contamination. And as the microfiltration do not able to do that removal of the dissolved contamination, dissolved solids. So this RO is the suitable, that is the reverse osmosis. The name itself, it says that it is the reverse of your osmotic process that happens into the nature. So it is the reverse of the osmosis. Reverse osmosis used in the used as a semi-permeable membrane. So it is a semi-permeable membrane. Applied pressure to push the water through that particular membrane, and leaving behind the dissolved salt, dissolved contamination, which has been blocked by the that physical barrier, that is the semi-permeable membrane. So the high pressure pump is always required when we are going for the RO membrane. And in the RO technology, we target the dissolved salt, the TDS removal, heavy metal removal, the some kind of inorganic also get removed. But if we are applying or using it into the microfiltration as a pre-filter, then that inorganic particles will get removed it out into the microfiltration. Many kind of organic, the bacteria, the virus are then getting filtered out from this particular RO membrane. This is how the same process happened. There's a membrane barrier, the feed side, the permit side. So whatever the contamination need to be filtered out, that will get remain into the feed, and remaining water will pass into permit side. But again, into the filtration, is a lot of much more wastage of the water take place. That is the high concentration of waste is being generated. So that need to be again planned, that how to dispose, way to dispose this kind of highly contaminated the liquid, which generate as a the waste from the RO filtration method. So the operational parameter or on which the RO depends, as I mentioned, that is the pressure. The pressure required is much more higher. That is as I mentioned, that it is the reverse of the osmotic pressure. So more than the osmotic pressure, we need to apply into the this kind of filtration process. So the pressure requirement is very high. The feedstock, if high dissolved solid concentration is there, so again the cleaning process will be much more more time the cleaning process need to be done. The clogging will be much more frequent in this particular process. So again, the what is the concentration or the characteristics of the feed water, that will depend, that will make the life of that particular membrane. The temperature also play important role. So many times you must have seen that if it's high temperature, that may cause damage to the filter membrane, or reduce the flux, increase the flux. It depends on the temperature, but there is no any kind of the treatment method where we can control the temperature. For the smaller unit, it is possible to do that, but when we talk about the larger unit, where the temperature control may not be the possible. So but still it going to affect your the working of the membrane technology or the membrane process. Next is the recovery, that as I mentioned, that the high wastage of the water has been generated, as well as the percentage of quality of water that we get from the after the treatment of RO membrane is much more good as compared to the microfiltration. Okay, the same problem in this also, the falling and the stealing and this kind of will be there in any kind of membrane technology. The suspended solid can block that particular the membrane pores, the sealing, because we are targeting the calcium carbonate, like the salt which are being present, the silica sulfate, so which can form the sealing onto that particular membrane. That is a physical sealing can take place. So that problem will be there. So how frequently the cleaning, the backwashing is required. It will, if you do the proper maintenance of the membrane, so it will help to increase the life of your membrane. It is a common difficulty into any kind of membrane technology. The organic biofouling, that is the natural organic and the microorganism form the film on that particular the membrane, which is a semi-permeable membrane. If some certain kind of microorganisms are being present, they may form the biofilm on that particular the membrane, and that will lower the flux and rise the cleaning demand. So cleaning frequency it will increase. So that again cause a problem into the membrane filtration. Next is the oxidation, such as the chlorine, oxidant as a chlorine. So chlorine act as oxidant. If the residual chlorine has been present into that particular water, that may damage that particular RO membrane. So that again is another difficulty that the membrane filtration, that is RO filtration can in the RO filtration can happen. So in this on this slide, we can see that what is the use of this particular RO membrane. So it is for the brackish water, that is highly concentrated water which is generated by containing the high dissolved solids or any kind of the dissolved organic matter. For that removal, we use the RO, the seawater desalination. So as a tertiary treatment for the water, wastewater, we can use it. It is also applicable for the boiler feed, where the low concentration of the salt has been required into the boiler feed water. So there also we required as a RO filtration membrane can be used, and can go for the application of this RO membrane. The point where we are going for the drinking purpose, reuse of that particular water, or any raw water using for the drinking purpose, there also we can use the RO membrane. So as I given the example, that's in our home, we have the water purifier, that is a small water purifier. In that, the RO filter is being installed. What are the benefits? The strong dissolved solids or reduction is taking place, that is the dissolved kind of contamination which are present in that particular water will reduce that. The compact module, so it required the less space, the high quality permit for the reuse or polishing, like we can get the much more high quality of the effluent from the RO membrane. What are the limitations? Need careful pre-treatment and the routine monitoring. As I mentioned, there are a lot of the functioning problems are there in the membrane technology. So the proper routine monitoring has been required. Required pressure, as the pressure requirement is very high in this, so we need to see that that kind of pressure we are able to maintain or not, and therefore the energy requirement will be high, and the production of the concentrated stream that generate from that need to be managed properly, need to be disposed it proper by doing the certain kind of again the treatment. The membrane falling, stealing, oxidizing of that particular membrane is again another problem in the membrane technology. For the RO filtration, so next is the ultraviolet light treatment. As I mentioned that for the tertiary treatment we can we can go for the disinfection process also. The disinfectant process can be any type, that can be the chlorination, it can be the UV light, ozonization, so any kind. So we are now looking at this one kind of disinfection process is the ultraviolet light treatment. So ultraviolet light treatment do not strain or dissolve salts or suspended solid the way the membrane do, but it helps. It is one kind of UV ultraviolet light we we give in this kind of treatment, and based on that ultraviolet light, it damage the microorganism, it damage the reproduction of that particular microorganism. They kill that kind of cells which have been present in that particular water. So UV light, it is nothing but the disinfection process. So for the disinfection process, we can use the UV rays. But there are certain, if we compare the different kind of disinfection process, there are advantages, disadvantages based on the of the different kind of disinfection process. The major disadvantage in the UV light is nothing but there is no residual formation is taking place into the UV light. So if you are needed such kind of treatment, in that place we can go for the ultraviolet light treatment for the disinfection process. So UV source is been there, it will damage DNA, RNA of that particular bacteria, virus or microorganism, and no further reproduction, no further growth of that particular microorganism. The physically that bacteria present in that particular water, but they cannot damage to anyone who is consuming that particular water. So that kind of treatment has been getting initiated in this. So next slide on this, we had seen that this kind of process. So this is your the effluent flow direction. This is the reactor in which the UV lamp has been installed. Based on the how much area of the UV rays has been required, based on that the calculation of the how much number of lamps has been required, and the contact time need to be decided, and how effective, which kind of contact time, how much contact time will be the suitable for that kind of water, that need to be decided, and how this functioning take place. So this is the some the again the dosage, as I mentioned that the exposure time, intensity of the light, so that will decide that what is the requirement, and that depends on what kind of contamination has been there on that particular, what will be the flow time is been required for that particular water in that particular reactor, that will decide what is the contact time. And then again the intensity of the light need to be decided, that required output, and based on that we can do the calculation of that. Advantages, as rapid microbial inactivation take place inside to the reactor, no chlorination need to be, that is no chemical need to be added. As I mentioned that each one has their advantages and limitation in this particular method as a disinfection process. The compact, it is a compact equipment has been there. Shorter contact time is required as compared to the other method. Again, it depends on the characteristics of the water, but still we can say the shorter contact time has been required in this UV process. It can be used for the bacterial contamination. It can be used for the other kind of microorganism, and there is no residual formations taking place. But no residual is again can be the limitation or the drawback for this kind of system, as the residual has been required for the future contamination once the treatment has been done. But if you are storing that water, if you are carrying that water through the pipeline, or you are storing that into the any kind of container, so there is no residual has been there. So if any future contamination take place, then it is going to get contaminated with that particular. So that is the drawback of this particular method. Need low turbidity, and good pre-treatment is then required. So if turbidity is high, the UV light may not be that much effective. So the good kind of pre-treatment is been required before going for the UV, as it may affect the efficiency of your UV light in that particular treatment. So electric power consumption has been there. So this kind of limitations are there in this particular process. So this is how the flow diagram of that UV can be used as a disinfectant. Okay, thank you.